Okay, partial fractions, P3. This is basically for Cambridge Year 13 A level. We are looking at partial fractions. It is good to note that partial fractions, we have type 1, we have type 2, we have type 3, and we have type 4, which is supposed to be maybe the highest type anyway. So in the previous video, we've talked about type 1, 2, 3, and I want to take you through type 4. So it would be good to watch the previous video so that you will be able to know what we mean by partial fraction. But just a recap, we have said that algebraic fractions with linear factors in denominators can be split into partial fractions, and this will give you type 1 as required. So if I have 1, let's say I divide this by x plus p, so I have x plus p, and I also have x plus q. So this is x plus q. This will be equal to a into x plus p, and then we have b into x plus q. So this is the first type of partial fractions. Again, we know that we use these methods of partial fractions to a kind of split irrational functions into maybe simpler component parts. That is what we are doing. These are rational functions, and we can split them into a simpler component part. So we have to choose which method to use by maybe looking at the denominator of the function and the numerator, and if they are the same, it will help you to know the particular type to use. So this is the first type of partial fraction that we already did. Of course, we are going to do more videos on this type of partial fraction. Type 2 is when we have let's say 1 divided by x plus p squared. So this is an algebraic fractions with a repeated factors in the denominator. So we have this repeated factor in the denominator. So in this case, we can split into partial fractions by letting, so it becomes 1 over, let me clean that up just a minute. So what we are going to have will be a, if I split, a divided by x plus p, right? We can add b into x plus p, but now squared. And you have to pay attention to see what is happening here. So in this case, it is a over x plus p plus b into x plus p squared. This is the second type of our partial fraction. This is the first, so this is second. Right. So what is the third type that we also discussed? It is that type of algebraic expression, or that type of algebraic fractions with a quadratic factor in the denominator. So when we have, sorry about that, a quadratic factor in the denominator, we can actually split that. So what I mean is that we have 1, let's say 1 is supposed to be quadratic, so I can have x plus p. Then I can have x squared plus q, because one of the power must be 2 in order for this form to be quadratic. So when you have this form of quadratic factor, we can split into a divided by x plus p, then we are going to have plus bx. Divide this by x squared plus q. So this is the third type. The third type of partial fraction that we already discussed. So today we want to now look at the fourth part. So in the fourth type of partial fraction, we are going to concentrate on improper algebraic fraction. So when you have x squared, let's say you have x squared into x plus p, and then we have x plus q. This is an improper algebraic fraction of that can occur when maybe a polynomial of degrees greater than or equal to number n is divided maybe by another polynomial of degree n. So when we do this, we can simply have a to be alone because this is an improper fraction. Then we add this with bx plus c, all this divided by x plus p into x plus q. So this is the fourth type in types of algebraic partial fractions. So let's now take a question in regard to these. Let me freeze this point and try to take a question as we see what to do about that. Just trying to make sure we have this part. Okay, so let's write down the question. So given the our polynomial function, we are supposed to express the given equation, or this a given expression, into partial fraction. So the first thing we want to do is to rewrite this into a standard form. So if I write this in standard form, A, just like what we have here, plus bx plus c divided by x squared plus 4. So we have x squared plus 4, but this is a cubic function, so we are going to have d plus d divided by now x minus 3 is what you have. This is d. So from here we can multiply through by the denominator such that we are going to have 3x cubic minus 5x squared minus 3x minus 40 to be equal to, if I multiply, try to cross multiply, I will have a into x squared plus 4. Then I will also multiply that by x minus 3 plus we'll have, let me open this up a bit. So from here now we are able to solve. We can start by letting the first value. Let's find what is a, b, c, d. So to find d, we can let x to be equal to 3, because we know we have here 3. If I find the root, we have x minus 3 is equal 0. Solving for x gives us positive 3. So if I let this particular part, x minus 3, to be the value of x, and then replace this on the left hand side and the right hand side, we will be able to find the value of d. Let's do that. So by replacing x as 3 on the left hand side of this equation, 3x, that is 3 times 3 power 3 gives us 27 by 3. So all this will give us negative 13 if we replace the value of x's to be 3. And when I check the right hand side, we will simply have x squared plus 4. In terms of d, we are solving for d, and if I replace that, it is 9 plus 4. That gives us positive 13. So negative 13 is equals to 13d. Solving for d, dividing both sides by 13, we have negative 1 as the value for d. So now we can substitute negative 1 back into the equation so that we can go ahead and solve for the value of x. To find now what is our a and what is, because we have a, b, c, d. Now we already got d. We need to find b, c, and a. So let's let x now to be equal to 0 and solve for that. Observe what happens when I let x to be 0. What you observe is that 3x cubic becomes 0, because it is like having 3 times 0 power 3 gives you 0, minus 5 times 0 squared, 0, minus 3 times 0, 0. So what we are left with on this left hand side is negative 40. So we have negative 40. Now we also do the same on the right hand side. We will simply have a into 4 by negative 3 plus c into negative 3. And if I do simplification, I will simply have 4a plus c equal 12. Call this your equation 1. From here, we can proceed to find what is a, b, c as we envisage by letting now x to be equal to 1 and solve. I want this video to be 15 minutes, so I am going to take you through some of the steps, but I will be fast enough to ensure that the time is not elapsed. When I let x to be 1, we see the left hand side become negative 45. You simply put 1 where there is x. And then the right hand side is negative 10a minus 2b minus 2c minus 5, which we simplify to get 5a plus b plus c equal 20. Call this equation 2. Let's proceed and now find, we can let x again to be equal to 2. Remember, we let x here to be equal to 3, x equals 0, x equals 1. But we need a, b, c, d. So let's let x to be equal to 2 and then solve. The left hand side becomes negative 42, and the right hand side gives us 8 into a, which is 8a plus 2b plus c equal to 34. Solving and simplifying, we get 8a plus 2b plus c equal 34. Call this equation 3. So now we have equation 1, we have equation 2, and equation 3. So now we need to solve and find the value for a, b, c, since we already got d. Let's proceed and do that. I will try to shrink this as I solve that. Looking at c, we have 12 minus 4a. Remember, from equation 1, 4a plus c is equal to 12. So simply make c the subject, so that we have this, and then by simplifying, we have 5a minus 4a gives us a, then we have plus b is equal to 20 minus 12, 8. So call this your equation 4, and then solve by substituting equation 2. We substitute in equation 2, and we will get 2a plus b, 2a plus b. Now we are going to solve equation 4 and 5 respectively. 4 is a plus b, that gives us 8. 2a plus b gives us 11. Solving, a gives us 3, b gives us 5. And c, we have 12 minus 4 multiplied by 3. That is 12.